In this video, we're going to demonstrate using DesignX to take 3D scan data and reverse engineer it to a CAD model. So we've got some scan data here, pretty straightforward data. You see here, the holes here were just where we had some reflective targets on the part. But other than that, it's kind of this block shaped and a shaft with a spline in it. So let's get started. So we've already imported the data. The data has come in a coordinate system already, but if need to, you can put it in a coordinate system. Now the first thing I'm going to do is I'm going to create some regions, okay? And what regions are is like basically you're color coding the data. This will probably make more sense here in a minute. It's not absolutely required for this part, but I like to use regions. It just makes, as you'll see here in the demo, it just makes doing things quicker. So, for example, I'm going to just, basically I'm using a paintbrush, and I'm going to paint the scan data here, here, here. There is an auto region, but I tend to use this. It's just faster. And I'm going to insert the region. So you can see it's color coded. Then I'll come up here to the end of the part, and even though this is really rough, that's fine. I'm just going to paint it because what I'm going to do is fit geometry through it like a plane. But I'm only going to use it as a rough kind of guess. So this will make sense in a minute. And I'll paint this plane back here. And basically the more of it you paint, the more data it's going to have. So all you're really doing is color coding the scan data. And as you may know, scan data is just triangles. It's not CAD data, which is really what we're trying to do here, is turn this into a full CAD model. Okay, so you can see I've just painted those three planes. I could paint other stuff if need be, but I think that's all I'm going to need for this. And I can always come back later and add more regions. Okay, so I've just color coded that. Let's turn on our planes. And DesignX is very similar to products like SolidWorks, Inventor, Solid Edge, etc. It is a solid modeling, feature-driven modeling software. So if you already know 3D CAD, a lot of this will make total sense to you. Okay, so the first thing I need to do is get a plane on the back because I'm going to build a sketch here, and that's why I built these region groups. Okay, so instead of having to try to I've got a plane here and then trying to have to measure back to here, what's really cool is I come under here and I say plane, and I pick that region group, and I don't necessarily know exactly where it's at, and then I'm going to say axis constraint direction, and I'm going to pick this plane here. Basically what it's going to do is make it parallel or lock it down to that plane. But what it's going to do is it's going to basically look at those areas I painted and average out that scan data. And I see I did a little preview here, and it's basically going to best fit a plane through all of that scan data, but making sure it's locked in the same axis as that that top plane I picked. Okay, so it's just a very quick way to get a plane exactly where I want without having to go and measure the data. I'm basically sampling the data. Okay, so let's turn off the other planes. We'll just keep this simple. So there's my first plane. Now I'm going to do what's called a mesh sketch. Okay, and I'm going to pick that plane. And then what I want to do is I want to sample the scan data. Okay, now right now it's drawing this this mesh sketch right at the edge of the part, which I don't want. So I want to move it in somewhere. And you can see I can slide around. It doesn't really matter. I'll go in right here, so where I'm not on the whole locations. But if you see back here, it's actually going to draw that mesh sketch at that plane. Okay. So again, if you look, you see this pink line. That's called a reference or mesh sketch. Okay. And it's at that plane, even though I sampled it up here in the middle of the part. So now let's turn off the scan data. Let's look perpendicular on. And now we're going to build actual geometry. So if you look at this, this part was probably forged and then machined, or cast and then machined. So you can see it, you can see here, that looks like, probably where the parting line was. Corners are rough, not everything is perfect. But when we reverse engineer something, we want to go back typically to the as designed shape, okay? Now it just depends. But typically that's what we want to do. Okay, we want to go back to the as designed. So I just made a rectangle. So now we're building real sketch data. And then I can also dimension this just like you would in a normal CAD system. Okay, so 5.9998. I'm going to guess that design intent was 6 inches. 5.2, that looks pretty good. I'll go ahead and stay with that. So there's my first sketch as a rectangle, but now I've got these cutouts here, and I can create those as well. Now there's a few different ways we can build those. One quick way might be, and this just gets into modeling technique and how you like to do things. We'll go ahead and just kind of eyeball this, okay? And then I'm going to build another rectangle over here, okay? And we'll make sure that those are parallel. Okay, so we've got that, and then I'm just going to start trimming up some of this. We've got a corner trim and a power trim. I'll do the corner trim. Trim this and trim. Let's do this one over here. Okay. And now I lose my one line there when I do that. I guess I could have probably done a power trim. Might have been the better way to do it. But either way, again, some of this just gets down to your personal preference. So we will trim out this corner there, trim out this corner there, and then we'll just get rid of that line there and that line there. And then I can always check for disjoint ends. If I see basically an aqua color that's telling me that I've got something missing. So that looks all good. So that's it. That's my first actual sketch. So just to review, let's turn our scan data back on. We created a region group. We then fit a plane through that region group, but made it parallel to the top plane. And then we built our first sketch. Now we're going to extrude. And again, this is another reason I like region groups. So now I'm going to actually extrude my first solid body. I'm going to pick that. Now, I can go in the side view and I can, eyeball it, and you can see there negative 5.014. And again, logic would tell me that's probably supposed to be 5, which is an easy way to do it. But the other way I could do it, let's just say it was some weird number and I didn't know. Let's do that extrude again, pick that sketch, and instead of doing a blind, I'm going to go up to a region, okay? And you can see it'll pick it there, and again, it's going to average it and give me that. So now again, I could go back and do it and punch in 5. That might be the right way to do it, but region group is another way. And since it's a history tree over here, I can double click on that extrude. I can say, no, let's go ahead and do a blind and, type in 5 like we had before. Ooh, and go the other way. Either way, so it's history tree modeling. You can always go back. So there's our first solid body, and you can see what that looks like. So off of that plane. So now let's go ahead and build this main shaft here. So what's neat about this, we're going to do a mesh sketch again, okay? And let's turn this off so you can see it. I'm going to pick that front plane, and then let's turn our scan data. And then I'm going to, again, come in here and sample this somewhere. It doesn't really matter where, assuming this thing is a straight projection. We'll go ahead and just pick out there. Let's go ahead and turn off our scan data, okay, and take a look. So we've got the circle feature here. That's an easy one to do. Just pick it, creates a circle, and then we've got like a key slot here. Same thing, I'll fit a rectangle and make some adjustments here. And we'll do trim. Power trim will be the way to go here. So trim that, trim that, trim that, and get rid of that. And there we go. So there's our second sketch, and we know it's going to be parallel because it's right there. Now, again, I don't necessarily know how far to extrude it, and that's why I'll hit extrude, and this time I will go up to region, and I'll again pick that, and it's just going to average that. It's going to look at all that scan data there and average it, and we'll want to merge that so it's one solid body. Okay, so there we go. I've got my second feature merged in with the first one, and that looks pretty good. So let's move on. Now let's come up here. We've got a chamfer on the end of this. Let's turn that off. Oops, turn off the solid body. We've got a chamfer there, and I have no idea what size it is. One of the really cool things when you do fillets and chamfers is you can say, pick the corner, and then you can say, query the scan data and estimate what it should be. So it's actually going to look at that underlying scan data. It comes back and says that distance should be 1.335. Again, we can say, well, let's make it 1.35, and the angle's 39 something. Let's make it 40 or 45. Probably 45 would make more sense, right? And then we'll go ahead and hit Oh, whoops, that didn't work out too well. Let's hit undo. I think I typed in something wrong. Let's try that again. Query that again. I think it was, yeah, sorry, 0.135. 0.135. There we go. And we'll make this 45. There we go. Looks better. Okay. So if we turn off our solid body, turn off our scan data. Okay, it definitely looks better. Okay, so we've got that now. Now let's go ahead and do our holes. Now we've got a couple sets of holes. Looks like on one side they're threaded, and on the other side they are smaller and maybe just through holes. Okay, and doesn't look like they go all the way through, or maybe at one point they did. So we're gonna have to, make some decisions there. But let's go ahead and work with this. Now, normally we don't actually put the threads in. We just put in the hole size, and then usually on the drawing we're going to call out the threads. So let's go ahead and do this. Bring our solid body back. Okay, and so let's go ahead and turn on our solid body. And let's go ahead. So we're going to do, again, a sketch. We're going to do a mesh sketch. I'm going to pick that plane. And instead of using the command where we move down and cut through, which we can do, that's fine. But the other neat way you can do it is what we call a silhouette, which is this one here. And you grab that, and if you look over, it's basically anything within this area. It's going to kind of find the average of all that scan data. Okay, so it's like a parting line command almost, if you're familiar with that. Okay, so let's hide our scan data, and actually we can turn off our solid body too. Okay, so the first thing, let's fit one of the holes, and again, this is a threaded hole, so we're going to want to determine what size we call that out at. Okay, so let's just make it, maybe the drill size is I don't know, we'll just make it 0.3. Okay, whatever we want to call that out as, doesn't really matter. And then what we're going to do is a linear sketch pattern, and we're going to pick this here, and we're going to go. So basically, we're going to do 3 by 3. And we're going to basically drag this to the center of that hole and drag this to the center of that hole. And we can come in here. And you can see the holes are off a little, but again, if we wanted to go, and we can key in amounts too on the spacing. Okay. And, there may be a particular pattern for this. Okay. So in this case, I'm just going to eyeball it because some of these are off a little bit. Okay. So that's that. Turn that off. Bring back our solid body. And I believe these holes were all the way through. Okay, yep. So this time when we extrude. Okay, let's go the other direction. We certainly don't want to go that far. We just need to go a little bit below. And we will do, in this case, a cut. Okay. So we've cut those holes. Now, a couple of them, let's see here, are actually not in that pattern, obviously. So we can, again, go back to the sketch. And even though we've made that linear pattern, we can delete that one and that one. And you can see, again, this is the beauty of feature modeling. Okay, so I'm going to make the assumption that these holes should follow the same center points of the holes above. Okay, and the size looks to be slightly smaller. So a couple ways we can do this. Let's do our mesh sketch again. Okay, pick that bottom plane, and we'll still go ahead and sample the data. Okay, just so we have, again, some reference holes. Okay, and let's go ahead and hide our scan data. But the other thing we can do, and let's hide our scan data for a minute, is we can bring back the previous sketch and show that. At a minimum, we can get the center points of the holes. And there's lots of different ways we can do this. Let's just pick and make one, and we'll just kind of eyeball it 0.18. Again, we can dimension this. Okay, so we'll make that 0.18. And again, we can do that linear sketch pattern and drag it out and up. And let's zoom in and get in on that point there. And zoom in on that point there. There we go. Okay, and again, let's turn on that scan data. And again, we don't have those other patterns there, so, or those holes, so let's get rid of that one and that one. Okay, so we've got our next set of holes, and I'm not sure, and we don't have a whole lot of scan data down into these holes. Sometimes you might go in and manually measure the depth of those holes. So since I don't know it from this model, I didn't do the actual scanning. I'm just going to flip it, and I'm just going to go, let's try a 1/2 inch, and that'll work, and we'll hit cut. Again, you can always modify this. Let's bring back our solid body, and there you go. Okay, so we've got those holes. They line up nicely. We've got our 2 sets of holes. So I think we've got one more feature left. Let's bring our scan data on, and there's like another slot right over here on this side. Now, I didn't do the region group for that one, so let's go do that. Turn this body off. And again, I could try to go in and measure a plane, but the region groups is so much easier. I just come in, region group, and you can use any of these selection tools. Okay, so maybe we use the, let's put this in a true view. Okay, that's the other side, so flip it around. So maybe a good way to do this would be with the rectangular tool. And again, I just want to get some sample data in here, like that. Okay, and you can see it only selected the one side. You can select if it goes through or just what it can see. Okay, so again, we have that data. I'm going to turn back on my, see, I'll need my front plane for this, right? Because I want it to stay parallel to that. So same thing. I'm coming under model, plane, select region, or sorry, extract, which is essentially region. And then I'm going to lock it into that plane so it stays parallel to that plane. So now I've got a plane right there. Okay. Now I come under my sketch, mesh sketch. I pick that plane. Now again, I'm right down at the bottom. I want to kind of sample up somewhere in there. Okay. And now we're going to use, there's a nice slot command. So let's turn off the scan data. There's a nice slot command, and even if I don't have all the data, you can see it's missing here. It's kind of rough. You know, it's going to figure it out. So I just window in and grab that. It's going to best fit a slot through all that geometry. That looks good. It makes everything parallel and tangent. Go back to model. Let's turn back on our solid body. We will extrude this, and that looks plenty high, and we'll do a cut. Okay. Let's turn off that other sketch. Okay, so let's take a look. There's no magic button that tells you you're all done. You just got to kind of look at your model. You know, we could put a fillet in here if you wanted one, but we've got our slot. Oh, one last thing. So we've got this out front here. Another neat command we can do, and I'm going to go ahead and go back to regions. Get that little paintbrush again, and I'm going to come in here. This looks like to me it looks like a cone, right? Now I could just make it a hole, but let's actually model it as a cone. And what I'm going to do is try to pick some data in here. And then what I'm going to do is fit a primitive. It's kind of a nice command for this kind of stuff. So I don't have a ton of data on here, but I should have enough to hopefully fit a. So again, I'm going to make a region group, and then I'm going to go back under model, and I'm going to do a solid primitive, and you pick what you want, a cylinder, a cone, whatever. I'm going to say cylinder. I'm going to pick that, and then you can extend it because we're going to want to, this will make sense, we're going to want to cut it away. And if we do a preview, you can basically see it's fit a cone, in this case, through that region group, and that'll become a solid body. So if I turn this on, turn that off, okay, you can see, yeah, it's a little bit crooked, but you get the idea. And I'm a little bit under, so if I double click it again, oh, actually, here's a kind of a neat tool. So what it actually does is builds a sketch. So now that it's done that, I can go in and edit the sketch and try to fix it. Okay, so I can, like, for example, pull this end up higher. It is parallel, so that's and it is perpendicular, so that should be good. Okay, so now you can see, and now what I'm going to do, so I guess it is correct. I'm going to go ahead and cut it, and I'm going to cut, sorry, not cut, I'm going to boolean, discard that. I'm going to boolean, and I'm going to, my tool is that piece, my target body is that piece. and I'll just cut that away. Okay. Great. Okay, so there we go. All right, so I believe that's everything. Let's bring back our scan data. And I think we've got everything. Now, the last thing we can do, which is pretty slick, is we can compare our CAD model. Let's go ahead and save this. The last thing we can do is we can do what's called the accuracy analyzer, and we can compare how our new CAD model looks in relation to the scan data. Okay, so we click here and click deviation from body, and basically, and you can set a tolerance zone. So here I got 4 thousandths of an inch. Let's say, hey, my tolerance is 0.01, 10 thousandths of an inch. And what's going to happen is everything in green, everything that's green is within 10 thousandths of an inch. Everything in the red direction is plus tolerance, and everything in blue is minus. Okay, so you can see, and if you look and I see me hover around, you can see here in the yellow area we're out by 0.0138, and over here we're under by 0.02. You can see down here. Now this is very common when you take a manufactured part, especially one that's probably very worn out, and you reverse engineer it, because again, we're designing back to the as designed, not the as manufactured, or let's call it as current condition. So we want to make everything flat, we want to make everything perpendicular. So we are going to see some differences, okay? But there's probably some key things like this cylinder, maybe the end of it. But if you look at that raw scan data, a lot of it is pretty rough. Let's turn off the region so you can see it. You look at the end. So I'm not surprised to see those differences. So once we're done, we've got our solid body. We can turn that off, and we can go back and make changes if we need to. And then we have two options to export this. We can come under here and say File, Export, pick our solid body, and we have all of our standard CAD formats: iJustStep, Parasolid, A6, and you even have native CATIA. Okay, so what that'll give you, let's just go ahead and do a step file. That's going to give you just a native file, right? So we call this bolt or whatever it is. Okay, that's going to give you a native step file. Now, the native step file will not include this history tree, right? This is all the steps to get this done. You're just going to get what's called a dumb solid, okay, or just a solid manifold. If you want to retain that actual history tree, you can come under here and so we're going to go under here and we're going to do what's called a live transfer, and that'll go to SolidWorks, Siemens, Creo, AutoCAD, Inventor, Solid Edge, and then a CATIA file. Now what this will do is actually roll back the history tree. It'll open up, you'll have SolidWorks in this case open, and it'll actually rebuild this tree in the native CAD system. Now, it works pretty good on SolidWorks, Siemens. It's a bit more of a challenge with Creo. Works pretty good with Inventor and AutoCAD and Solid Edge. And then for CATIA, you just get a native file. You don't get the history tree. But if for some reason you did want to be able to edit this file and get the history tree, that is your other option, is the live transfer. Okay, so basically it's done. Probably took us 10-15 minutes here to get done. So that wraps this up. It took about 15-20 minutes, and you can see we've got a nice solid body.